All right, hello. My name is Mauricio Cisneros, and this is going to be my project presentation for the design document, the program, and the coding included for my hyperbolic calculator program. So, let me do a quick rundown of the design document first. First off, you have the introduction, which is just the prompt that I was given for this project. Write three MATLAB functions to calculate the hyperbolic sine, cosine, and tangent functions. Plot the shapes and compare the results of the functions with the built-in MATLAB functions sine h, cosine h, and tangent h. So when I first started out this program, I did not know anything about graphical user interfaces or hyperbolic functions, but I did put them to use in this program, and it was a fun experiment and I enjoyed it. So let me explain to you how this works out. The requirements, first off, the input and the output. For the input, I just require the values that are needed for the X range. These are input by the user. I just need the minimum value, the maximum value, and the increase of each variable. These will be explained later when I run through the program. Um, I also needed a possible way to change between each function. So I need a tab for sine, I need a tab for cosine, and I need a tab for tangent, so I can compare between all three of them. Uh, this was integrated in the user interface. And obviously, since the prompt asked me, I need to compare the built-in functions. When I say built-in, it's the MATLAB functions compared to the ones that I designed, that I made through MATLAB. I made them into functions. So that's all we need for the input, and for the output, we just need the graphs. The graphs will be shown in a tab method. As I mentioned, you'll see forward how that works. Uh, as for the algorithm logic requirements, we basically just need what I just said, both the user design functions and the built-in MATLAB functions. Both will be plotted, and all of them will use the graphical user interface as a tool to be plot. For the data requirements, it's basically the same thing. Uh, you need those files containing the functions. So I made three separate files for every function. These will be the only input that the code requires, other than the x values that will be asked from the user. And the output data, it's all going to be stored within the program. These will be the graph results. And as for the technical summary, the program is obviously written and run on MATLAB. Elements of the graphical user interface were created using the guide and app designer functions. I would like to say app designer is a little bit more practical and easy to use. I found myself around it much faster than guide. And as I said, the three set of hyperbolic functions are used in the programs. What's a hyperbolic function? They are analogs of the ordinary trigonometric function, so cosine, sine, and tangent. But instead of using a circle, it uses a hyperbola. And this is proven in the program. You'll see in a couple minutes. And the main design principles that I use are dry, which is don't repeat yourself. I cover that using modularization and the single responsibility principle. As for the pseudocode, I had three main goals in mind. The first one is I need to design the functions, the hyperbolic functions, which are named tan h1, cos h1, and sine h1. And I needed to design the graphical user interface so you can see the graphs and you can input your x values. And talking about x values, I also needed a way for the user to input those values. So I made the xmin, xstep, and Xmax variables, which sound just what they mean. This is the minimum value, this is the increase, and the max is going to be the maximum value. This is a short, pretty tiny look at the program. You can see on the left we have the value window where we can input the values that I just mentioned, and here on the right you can see the graphs for both the user designed function and the MATLAB integrated function. Uh, as you can see, they look pretty alike. For the testing, I added a couple of error messages whenever someone tried to input something that was not a float, that was not a numeric value for the X values. And yeah, I just double checked the results from these graphs on other graphing utilities just to see if they matched, and they did pretty faithfully. I didn't see any discrepancies. I had a different idea for this project at first, but it ended up taking a little bit too much of my time. I might do this on my own later, but it included a smoother real-time animation of the graphs, simultaneous plotting of functions in just one graph instead of having them, spread out, and color coding for those functions. As you can see, these are only blue. I wanted a red one, a blue one. They would have overlapped anyways. So no harm, no foul. And that's pretty much the design document. As for the program, I'm actually gonna leave this up. I don't want you to see my messy desktop. You can see this is the program. So here, let's focus on the right side first. We have both of the graphs. This one pertains to the user design one, the ones that I designed, and here is the one for the integrated MATLAB function. And this works not only for cosine, there's also one for sine, there's also one for tangent. And here on the left now we have the values window. So here's where we basically enter the values that we want for our minimum, the steps, the value increase, and the maximum. And once we click the plot button, it should give us the graphs for those functions. And as you can see, they're basically identical. The same can be said for the sine, and the same can be said for the tangent. And this, you can keep changing the values to see how it changes. It's kind of just going to be the same shapes as long as it has symmetry. And there we go. Now, as for the code, let me open the MATLAB. So you can see this is if you've handled graphical user interfaces with MATLAB, this is basically the app designer setup. But what we care about is going to be right over here. This is basically all the important code. First off, when you push the button, the plot button, right here, is basically what sets the program in motion. This plot button is what connects to the plot button push function. And the event that happens are a couple of things. First off, it ties the values that we get from these windows over here, the minimum, increase, and maximum. It ties them to the xmin, xstep, and xmax values. Those are then formatted, so this becomes our general x value. This will be used later just for the sole reason of inputting it in the plot function. And here is where we use the functions that I've made. Cos h1, sine h1, and tan h1. These are the ones that I made. And once you grab the x value, it'll bring back to this variable, which is the results from the x value. Say the same is done with the integrated MATLAB functions. So we just have this block is just dedicated to the user design ones, and then this block is dedicated to the integrated MATLAB ones. These are then plotted, and as you can see, each one is related to a different axis, which is a different graph. Then I input the x value, which we already explained, and then we input the y value, which is the result from all of these functions right here. So if you recognize how plot works, you first need to input where do you want to store the the results. Then you input the x value, which coincidentally is named x value, and then the y value, which is the results from our functions. And that is pretty much it. Thank you for watching, whoever you are, professor, student, anyhow, and please give me a great grade. Thank you.